Hello and welcome to this talk. It's a pleasure for me to see you here, and as you can see, I'm in the woods. I'm on a small hiking trip, and it's a perfect time to be out here because it's a little bit foggy, it's a little bit raining, and nobody else is here. So perfect time to see some animals, and it's a perfect time to think a little bit about object-oriented persistence. So what we want to talk today about is, I want to talk a little bit about object-oriented persistence inside the JVM without adding the next big subsystem to it. So how you can achieve lightning fast persistence inside the JVM if you're talking about microservice or serverless functions or whatever, just in these tiny applications. So if you're interested in how we can achieve this one, how Docker Desktop can help you with this development cycle, and if you want to see how I'm developing a small app that is based on open source projects and will give you all the capabilities to store complex object graphs inside the JVM on disk, then you are right now here. By the way, my name is Sven. I'm developer advocate for JFrog, and I'm focusing there on the topic DevSecOps. And as you can see, I'm mostly in the woods. So if you're interested in cybersecurity or Java related topics, check out my YouTube channel. You will find a bunch of outdoor IT related videos. So then, if you're the first time watching a video of mine, then a really big welcome, and I really would like to see you as my new subscriber. So if you like this video, give me a thumbs up, subscribe my channel, and let's start. Okay, before we are talking a little bit about the object-oriented persistence and what tools I'm using and how to deal with this one, I want to highlight a little bit the theoretical background, and then I'm dividing the application itself mostly in 3 layers if you're talking about the persistence. The first layer is the app layer. The app layer is holding the business model, and the business model is the data model you need to have a right transformation from the use case itself to the technical implementation. And this data model you're building based on the data structures you have in your language, on hash map, or on list, or on queue, or whatever. So at the beginning you have core data structures. These core data structures you're bringing into a composition, and this composition is your business model or your data model you need for your use case you want to write in your language. And this is optimized for the business use case. It's not optimized for speed, for performance, concurrency, whatever. It should be optimized for the use case, nothing else. This would be exactly the data model or the part you're writing to earn the money. Everything else, what's coming up now, is something that you have to do based on technical things, so requirements, but it's not really necessary to fulfill your use case. So everything else what's coming up next is just something like a technical cost and nothing you really want to have. And the next thing what I want to highlight is, for example, the caching layer. Let's talk about the caching layer. So the second layer in the 3-layer model, what I'm explaining right now, is a caching layer, and this is the first layer that we only have because it's not fast enough or the persistence needs some technical changes. So the caching layer itself have to manage all these weak parts of the model if you're talking about persistence or complex object graphs. So loading stuff and storing stuff and making sure that all the bits and pieces are synchronized so that you can work on this persistence layer efficiently. So the caching layer itself has some technical requirements in many cases, so they are not supporting all core data structures in the same way. Some caching layers are good with hash maps but bad with lists or whatever. So it's just an example. But the main thing is that now you have to transform the first time the app layer to the caching layer based on technical requirements coming from some framework you're using, and this is mostly just done because it's not fast enough. So it's nothing you need to earn money, it's just a technical cost. So the caching layer itself is the first data model transformation. You have technical requirements, you have different behavior inside this caching layer, and this is something, it would be perfect if we can get rid of it. But after this, we have the next layer, and this is a physical persistence itself. The third layer, and the last one I want to mention here, is the layer of the physical persistence. So most systems have this physical persistence layer, so it means really the layer that will come from the object model or from the caching model and try to store bits and bytes on disk. Traditionally, we have external processors. It means to store data, the caching layer or the app layer has to communicate via inter-process communication to some system that is able to transform the information to something that's stored on disk. So we have different systems. I want to talk a little bit about this one in a few seconds, but the inter-process communication will give you some requirements. If you have a complex object tree or object graph, then you need to transform it in some kind of serialized stream so that you can send it over the wire. And then on the other side, if this persistence system is not exactly in the same language written, or it's some kind of different technology, then you have mostly some mismatch between types. So an int on the one side is not the same size as an int on the persistence side, and so on and so on. So you have the second time the need to transform stuff. So your app model and the data types you're using inside your app model, you have to transform, you have to think about how to map this one. And if you're coming from the app model, this is a transformation, or if you're coming from the caching model, it's mostly the same. You have to transform again the model based on technical requirements, and you have to deal with inter-process communication, you have to deal with different technologies and the behavior, and so on and so on. So at this point, we are not talking about different semantics, so SQL, object-oriented, document-oriented, or whatever, but we are just talking about you have to store all this stuff in a different way so that's persistent on disk. And this is again a technical cost that is not nice, and if you can get rid of it, it would be perfect. The next thing I want to talk a little bit about is how stable is your data. So why this is important. First of all, it's important because if you know how stable your data is or what part of the data is stable, then you can make a lot of technical decisions that makes your life easier instead of just going always from the worst case that you need everything, every technical possibility. So it's important to think a little bit about the data and the data behavior so that you can make decisions to make your persistence layer easier and more performed. Let's talk about the different behaviors or the different data groups I have in mind. The first one is the easiest one. It's just dumb down. So writing it once and never touch it again. It could be log files, transaction logs, raw data from sensors, whatever. So it's really, you will get some data, you have your model, and you just have to persist it. That's it. So it makes your life really, really easy if you can grab some part of your model like this and treat it just like dumb it down. And you don't have to think about how to query data or how to manipulate data. So if you have this one, so just reading data, storing it to disk, that's just the easiest part of persistence. The next thing, if you're not just dumping down data, is if you have a sliding window of hot data. What does it mean? It means that you have, for example, the last 24 hours of data, you can manipulate, you have to search, you have to work with this data, so data is changing, and after this time, this sliding window pass over this time range, then this data is just stored, archived, and read only again. So sometimes you have this behavior, so you have just this tiny sliding window compared to the rest of the data, and if you are able to extract this behavior, then you can think about different storage techniques, so how to deal with the sliding window instead of having access to the full range of data. Okay, the worst case is if you have all data hot. So if you have no sliding window, no dump down data. You just have to deal with, I need all data all the time. I can modify everything, I can recombine it, I have schema evolution, and so on and so on. So this is the worst case. So yeah, so now we have the three things. So write and dump down, don't touch it. You have the sliding window. The next more complex part, and the worst case is you need access to all data every time. You can modify everything. So think about this one. What part of your model will have to deal with this requirement? Dump down, sliding window, or all data hot. And maybe you can divide your model in different persistence parts so that you can deal more efficiently with a part that are with low requirements or lower requirements. How to access data. So if you're talking about a persistence layer, you want to make sure that the way to access data is fulfilling all your requirements. And this could be, do you need a query language? Do you need a language like SQL or Cypher based on the different data behavior? Do you need to describe graphs or graph algorithms? Do you want to do it more like SQL, or do you want to have it more imperative like working on streams? So think about what is the best way to access data, what are the requirements for this query languages or the way to access and ask for data, so how to formulate the questions against your data. And the last thing I want to mention here is, do you need some features like virtual views? Do you need something, the possibility to calculate dynamic fields on the fly? Do you need the possibility to aggregate things or functions like a sum or an integral or whatever? So think about the mathematical things you need, what kind of functions you need, and if you need something like virtual views, virtual attributes, on the fly calculated attributes, and so on. Okay, let's talk about object-oriented persistence, or what do I understand if I'm talking about object-oriented persistence. Object-oriented persistence is something that will give you the possibility to model an object-oriented graph, not a tree, not a list. I'm really talking about a graph with cycles. So everything I want to have in my object graph, and then to persist it in a way that it's exactly the same. So just have this object graph and say persist. What could be part of this object-oriented persistence, or what must be part of this object-oriented persistence? So first of all, if we are talking about persistence, I'm just thinking about there is this graph and I want to say persist it now, and then I have something like a snapshot. So it's persistent. So that's it. Then I can navigate through this object graph, I can manipulate this object graph, and then I can say again persist. And then I have the next version of this object graph. So this is more or less object-oriented persistence. And then you can have different graphs. So if you have a car, this is an object graph, this car, and you have a second car, then you have two object graphs, and every single object graph you can say persist. So car number 1 and car number 2. Is transactional behavior part of object-oriented persistence? Yes and no. It could be part, but it must not be part of it. If you are thinking about this atomic behavior of I have this graph, this single graph, and then I'm just persisting it. Do I need concurrent access to this? For sure, in some kind of concurrent access you need it, but this is something that is on top. So if I'm talking about object-oriented persistence in general, I mean I have the possibility to hold a graph and just say safe. That is object-oriented persistence if I'm talking about it. So what's my feeling about object-oriented persistence? And then you need some kind of technical requirements like concurrency or transactional behavior and so on and so on. But think about your object model in a way that you have this logical root, and in this bag or whatever you have for this logical root, you have a bunch of different object graphs, and then every single object graph will be persistent and then you have the whole object graph somewhere. So this is what my understanding of object-oriented persistent is, but they are older traditional systems we have, and let's have a view on this one before we are deciding how to deal with object-oriented persistence in our case. Okay, it's not the first time that we are talking about how to store object graphs, and we had this technology already, and it was called object-oriented database management systems. And in the Java world, we had this, I think, beginning 2000 something, and we had different systems that tried to be something like SQL stores, but in an object-oriented way. And they had this idea of being this generic object-oriented storage where you can connect from different languages to store object graphs. But they were so influenced by the SQL stores that this was more or less a bad decision, because this language-neutral storing of objects had some weak points from the mathematical point of view. And the other point was how to query. And again, they looked at the SQL stores and created this OQL, so this object query language. So what we had was an generic object-oriented database management system with transactions, with a query language, and in a generic way as an external process. And this was not really taking off. So it was maybe the wrong time, maybe the technology was not good enough or whatever. So it was not really taking off. So object-oriented database management systems, they're more or less a dead horse. So all implementation of product I know so far died over the time because they had always these performance issues. They were on a technical level that you can deal with this, but it was never ever so performant or so robust in this kind of handling like the SQL stores at this time. So object-oriented database management systems, yes, we had it in the past, but they never took off, and there are no really, there's no product available, at least for the JVM world, that you really have this possibility of this dedicated object-oriented storage. So this was more or less a dead horse all the time. We saw that the object-oriented database management systems try to copy the SQL, the relational database management systems, in a way that you can store these objects in a generic way. And now looking at this relational database management systems, what they give us, they give first of all the mathematical background of relations, or these tables and relations between tables. We have different implementations over the time, so it's really the relational database management systems, they are very robust, they are good, they are performant and all this stuff, so don't worry. So this is really good thing, but we have always to map to a different technology. So if I'm talking about this relational mapping between one class is one table, for example, because we want to map it, and then the connection between classes or two attributes via relational tables and so on, this is one thing. We have to map some kind of inheritance to these tables and so on. So we have different approaches to do this. I don't want to go too much in detail here, but I want to highlight this relational database management systems are very good developed systems. So they're robust, they are fast, they're dealing with a lot of statistics internally to speed up things and so on. So we have there this cool approach of relational database management systems, but I have to map my model to this relational database management system, so to these tables, and I want to get rid of this one. So talking about object-oriented database management system with the technical requirements, earlier days mostly was you have to inherit something or you have to implement an interface. On the other side, the relational database management systems that you have to map your model to tables, you have to map your int to the corresponding type inside this database management systems. We want to get rid of all this stuff. So what can we do to just forget this mapping stuff, to get rid of this technical transformation between different technologies? Because what we want to have is we want to have something that is specialized on Java. And even if we have relational database management systems in Java, they are not so performant, and they never really took off in general. So, but whatever I want to say here about these different technologies, it was maybe too early, it was maybe the wrong time, but now we have the time or the possibility to be inside the JVM without this technical requirements to store object graphs. Talking now about this object-oriented persistence, so getting rid of object-oriented database management systems and relational database management systems, just talking about I have an object model. And mostly I want to create this model, okay, I want to store data, okay, and then I want to search for different attributes or different parts of the graph or whatever. So what possibilities do I have to speed up searches or to search in general? So the first thing is I'm just doing a brute force attack. So I have 10 graphs. For example, 10 cars. I want to have all cars that are red or blue or have 4 wheels or whatever. Then I'm going just step by step through all the entities and try to find it. So this can be a valid approach if you have just a tiny amount of elements, whatever tiny is for your requirement, for your amount of data, for your system and so on. It could be 10, it could be 10 million. I don't know. But if you have for your system a reasonable small amount of data so that you can just iterate over it. So that's one thing, to find something. Okay, that's one thing. If this is an approach for you, it depends on the amount of data and the situation. So it could be a valid approach to make it simple, just iterate over everything, filter what you need, and that's it. How can I speed up searches in my object graph? So theoretically what you can do is you start sorting data. So if you have a list of cars and you're sorting them, for example, with the amount of wheels or the horsepower or whatever the attribute is you want to search for, then it makes sense to sort data, and then you can do different search algorithms on top of this sorted data. And then you have to decide if it makes sense to sort data and then having a bunch of queries on top of it. And this is the first time you have to think in an object-oriented world, and with object-oriented persistence, is it worth to sort data because you have just a tiny amount of inserts, deletes or modifications compared to the amount of queries. And there is a barrier. So if this is more expensive to sort data, then maybe the brute force attack is easier to do or better because you're wasting less time. But sorting data is one of the things inside an object graph to speed up searches. And the third option is, for example, that you're using data structure that will give you with a fixed amount of time and result. So, and here we are talking about inverted matrix or about hash maps. So you have different attributes from your object graph and you're storing this combination of key and value inside a hash map. And for object-oriented model, this is a valid thing. So if you want to have all green cars, then you have a hash map. If with the key is green and then the value is a list of all corresponding cars. So you have managed indices or managed index. And this is something the relational database systems are doing on the fly based on the table. So they're analyzing all this stuff. So, what are the good queries and how often they are performed? It makes sense to build partially index. Or you can do it on purpose, that you say inside this database management system, create an index based on the following attributes. And the same you're doing in the object-oriented world. And then it's very convenient if you have these objects, if you have these hash maps, and you can just say store everything together, and then you have exactly the same thing. So you're speeding up searches. So if you're talking about object-oriented persistence, and we are talking about some query language and DSL, or if you are just going via streams over it, we have to think how to optimize the object-oriented model against the queries you have. So if you know more about what queries you have against this model, then you can optimize with, for example, hash maps, the speed of queries. If you don't know it, then you have to iterate and then you have to follow the path inside your object graph. So that is something we have with every system because it's just a mathematical background of how to speed up searches. Okay, we had a lot of theoretical background and now it's time to see how it looks like in code. So I will show you now how we can write this object, how we can persist this object, how we can build it inside of an application, and how this development cycle is done so that you can start dealing with object-oriented persistence directly in your own project. The whole source code I will deliver via GitHub, so I will put here or there or somewhere the link to the GitHub repository so that you can just fork and clone the repository and start with your own experiment. But now back to the office and let's see what the IDE will show you. Okay, I'm back home again and now it's time to play a little bit around with the source code and to show what object-oriented persistence could be with an open source project. But first I want to show you the example object model I'm using here, and this is just a car with wheels, an engine and so on. You will see it, and it's used here with JDK 17. JDK 17 is a long-term support version and it's the latest available right now, so there is no limitation in the version of JDK you're using, so feel free to use something between 8 and 17, and I think even 7 and 6 is working. So, okay, the attributes here are, it's just a regular class car. I'm using it inside a class, so this is why it's a static class. There's no deeper meaning behind it. But I have complex attributes like an engine and a list of wheels and then traditional getter and setter. The engine itself is again based on complex attributes. One is a list of cylinders and the other one is a static attribute, an int. It's the horsepower from this magic car. Just to use some new language features, I just used records for wheels and cylinders. Now attributes in, it's an attribute in the size for both, but there's nothing fancy. So what do we have now? We have a tree of classes. So an object is now not only with one-to-one references, we have lists inside, we have records inside, and so on. And with this, we want to play around a little bit. So for this example of object-oriented persistence, I'm using an open source tool called Microstream, and this is initially created by a company in the south of Germany, and they want to work a little bit more on this project. They use pre-versions of this in their consultancy company a longer time ago, and now they want to make a product out of it. So it's already battle-proofed since a few years, and now it's extracted in this company called Microstream. They have the seed funding, now looking for the Series A, and they open sourced the whole source code. So this is the Microstream homepage. You will find it under microstream.1. You find documentation and something, but the first step I would recommend is GitHub, and on GitHub you will find it inside the group Microstream -1, and the repository is called Microstream. Here you can create bug fixes or issues or bug reports and whatever, so the typical GitHub workflow. And you have this README with examples and reference documentation and so on. If you want to see more videos about it, check out my YouTube channel. I really would like to see you as my new subscriber. There you will find something about Microstream, some other open source tools in this high performance area, and as well as cool Java topics or DevSecOps, so cybersecurity related stuff. Okay, enough. Now let's start with the source code and with the example. That's the basic concept with this Microstream approach, and this is called root node, and then we are dealing with storages. So the main thing is that I need from my object graph one point, that's the reference point from which I want to start to persist all this stuff. And here I'm creating a class called root node. So if you have just one car with some attributes, you can just say the car itself is a root node. If you have different cars, you can use a list and then put all the cars in, and then the list of cars is your root node or whatever. I will show you what other things can be part of the root node. This we will cover in a few minutes. But so far we have this root node, a class that's a holder, and from this I can access all the other underlying graphs. So what is an embedded storage? The embedded storage is exactly this storage that's pushing all this stuff inside the JVM to the persistent store, to your hard disk. Then you have different other embedded or other stores that can use other persistence layers, so that you can have this convenience of Microstream on top of a regular database or whatever persistence you want to take or use. But here I'm using the embedded storage, and here the embedded storage, you start it and then you're giving the root node, the reference, and you're giving a path where you have to store all this stuff. Later you will see that inside this _data folder you will see all these different folders, and then you can analyze a little bit the binary storages if you want. So next thing is that I have my embedded storage, and then I'm connecting the root node. So then the connection is done, and then I just have to say store. So store root, and that's it. Then I can work on this whole graph, and at a dedicated point I'm just saying store, and then the whole graph is stored. And if I'm done with this, then later I'm closing the storage manager and can shut down the system. If you're just shutting down the JVM, there's a shutdown hook registered, and it will do exactly the same here for you. Okay, so far the basic concept of the root node and the embedded storage. Let's see what we can do. We saw how to store the root element, or we saw how to store attributes. This is quite easy, but how to get them back and how to work with this. And the first question is how to get or how to formulate a query. We don't have any domain-specific language, or we don't have any syntactical stuff like SQL to formulate queries, but we can use here just Java. And if the amount of elements is not too big, we can go to the root node, grabbing it, making a stream out of all elements, going through the attribute I want to use as a filter criteria, doing this one, and extracting the stream or the list of result elements back. So this is a quite easy thing, and you can formulate this query like a predicate. I have it here uncommented, so you can really create this predicate, and then it's more or less a collection of queries you want to provide for other colleagues, and then they can just use these queries to ask against the system, or formulating this stuff by themselves. You have all possibilities that Java will give you, or you can use a different language like Kotlin to formulate these questions. It's really up to you. It's performant for a reasonable amount of values. I don't want to say numbers, because it really depends how big is the graph, how many elements, what's the amount of memory inside your system, and so on and so on. But for a lot of basic questions, this is just a valid approach. But how to speed this stuff up, I will show you now. How to speed up queries that you have against your object graph. And the first thing what you could do is optimizing for convenience and optimizing for speed. These are different things. So quite often I see in this object-oriented approach that we have this convenience method. So for example, I want to ask the query against this graph, give me all cars with a certain amount of cylinders, for example with 4 cylinders. Instead of going to the car, loading the engine, loading all cylinders, giving the sum back, I see this convenience method. From the object-oriented point of view, this is right. For example, here, this amount of cylinders, and then here you're indirecting the query, so with get engine and get amount of cylinders and so on. So this you're doing this on the fly, but this is not really in speed up. What in speed up would be is if you have quite often the query against the system's amount, I want to have all cars with 4 wheels, for example. What you could do is you can add an attribute to car with amount of wheels, and this is a calculated attribute, and for this you need dedicated methods like add wheel, and then you are not only adding the reference of this wheel, this object itself, and you are incrementing this attribute. So it's a quite clear and straightforward strategy. You have to check that this is in an atomic way. I don't have all this exception handling here. So if you're adding a wheel to a list, but you're not adding the attribute and so on and so on. But in general, it's easy enough so that you can say, okay, if I'm adding a wheel, I'm adding the wheel itself and I'm updating the corresponding attribute. And then you would create here this list of wheels in a way that you have a lazy reference. That means if you're loading the car, the wheels are not immediately loaded. They're just loaded if you're accessing the wheels the first time. Okay, so this so far, with this I'm now able to create faster queries, and this makes sense to have a little bit more computation time during the time you're adding or modifying the amount of wheels, and you're quite often asking this query, give me all cars with 4 wheels, then this trade-off is worth. Okay, so but what can you do as well? So what else can I do to improve performance against an object-oriented model if I want to store and work and search inside this model? Well, I can use this construction of a root node because I have here a possibility to store something like a global index. You can do it in partial graphs, but you can do it in a global way. Here I'm just implementing it in a global position or at a global position as an example. And let's assume I want to have again all cars with 4 cylinders. What should I do? So all database systems or other persistence systems, what they're doing, they're creating an index, an inverted matrix. And this is done on the fly, this is done on purpose, or I have to declare an index. If I know this is a query I'm often using against the system. And here it's exactly the same. If I identify a query that's very often used against the system, and it would be a good trade-off to calculate a little bit during modification and to have a strong speed up, then I can use a hash map as an construction, as an index. And this hash map is not transient, it's part of the root node, and with this it is persistent. So if you're storing this stuff, if you're reactivating this stuff, your index is part of this as well. And then with all this maintenance stuff you can add or just define. Here, for example, I have this global method add a car, and then I'm going through this car, I'm going through all these attributes, and I'm using these attributes to fill this in the corresponding index hash mapped. And here I'm just using the compute if present method, and the key is the answer. I want to have all cars with 4 cylinders, and then the value of this hash map is a list of attributes or instance of a class I want to have. And this I can do on a partial part, I can do it in a global part. It's really up to your needs, what you need. What I'm not covering here right now is concurrency or atomic behavior like this multi-version concurrency control, commit and rollback. But in general, you have this possibility. You can speed up if you know what question is used, and then you can build an index like in every other persistent store if needed. After we saw the theoretical approach or the basic source code dealing with Microstream, I want to highlight some integration. So other open source projects like Helidon from Oracle see that this object-oriented persistence and this implementation of Microstream is quite cool, and they started with integrations. So what's Helidon? Helidon is here this servlet container. It's a microservice kernel with a REST interface, and what you can have is this open source project with the possibility to create your microservices as well as corresponding Docker images, Nata images, and so on and so on. There is a whole ecosystem around. If you want to read more about this open source project, go to helidon.io. You will see some documentation there. It's available in a micro profile version and in an SE, a core Java version. I'm using the SE version, and then you will find on GitHub the source code of this project, and there is the integration. It's on Oracle/Helidon, that's the project and the repository. And then you will find under Helidon examples integrations, this Microstream folder. Then you have these 2 examples, the micro profile version and the SE version. And what I've done is just I copied the SE example into a separate project, so that's a smaller one, and I will show you how easy it is to use this object-oriented persistence in this reactive environment, and how much code is used to implement the persistence and how much code is used to put it inside this framework. So let's have a view on this implementation, how this persistence is combined with this reactive implementation, this Helidon project, and what they have done. So they need inside Helidon these services at the main construction so that you can jump inside this Helidon framework. I don't want to go into too many details of the Helidon framework. That's a bigger project, but you will see that it's a quite straightforward way how to deal with concurrent modification or concurrent access through this object-oriented persistence we had. And this object-oriented persistence itself has no MVCC on top or stuff like this, so no transactions. So here this greeting service is implementation of a service. It's just a functional interface where you can see, okay, I have to implement a method here, this update of configurations or paths. So what they have done, they have here this constructor, and you will get this configuration. We will see how this configuration is created. And then out of this configuration, I'm grabbing this attributes. These attributes, you will see, they inside this application YAML. And here you see that even the Microstream properties you can put in this YAML file and use this later for configurations. Okay, greeting service. If you have this one, the next thing is you are creating this Microstream context. And this context is used here for connecting to the persistence. So let's see what inside this context is. This Microstream context will get this embedded storage manager. We'll see where it's coming from, but I have here all these logical methods like add and log entry, for example, and you can see what's going on here is inside my execute, so inside my completely future environment, what I'm using, I'm creating here this action, and inside this action I'm going to my storage manager, grabbing the root, creating new entry, adding it and storing it. That's it. So it's exactly the same behavior what we have in the single main project. So just modify the object graph and save. That's it. So what they have is an init. For example, if you are starting it the first time and you don't have this initial root node or this root node initialized, they do it here on the fly. So they check if the storage manager will have root. Here it's for all log entries. They have a list, and then they are just adding the log entries. And this they are just initializing with a new instance of an array list. And then store root. That's it. If you want to get logs, surprise, surprise, you're using a completely future supply asynchronously. You're grabbing the storage manager, grabbing the root node, and this is here just a list of log entries. So it's a very easy implementation. But how to deal with concurrent access? They're defining here for this complete future a dedicated executor. And this executor, if you're looking here, what is this is, you will see that this executor, where it is here, this executor is a single-threaded executor. So inside this reactive environment, they're using an executor for the complete futures. You're using a single-thread executor, and that's it. So this is their way to implement a straightforward or an asynchronous way of dealing with the storage root. You can now play around with different approaches, but this is a very lightweight and easy implementation, and it works. So it works and it's fast enough because Microstream itself is really fast. So if you're comparing now the code that's necessary to deal with the persistence and what's necessary to integrate it, you will see that the persistence itself is really, really easy, and the integration is more or less some work, and this depends on the external framework. But here, this is an official implementation. It's an official reference implementation for the Helidon project, and it works quite well. So it's performant enough so that they're using this as an best practice example. Okay, so now let's see what we can do with Docker and how we can make this a little bit more secure if we are scanning this against known vulnerabilities. Okay, after we saw this code, I want to start this main application here to start this Helidon server. For this, I'm just starting it inside my IDE. After I started this one, I see here this log message. It showed me, okay, it's running on port 8080, and we want to test it. So, testing it, I can here clear. To test it, first of all, I will check here what are the log files. The log files are 0, there is no log file because we haven't done anything so far. Then we are greeting someone, for example, Mr. Joe. I think he is Mr. Joe. Now I have this ping pong and there isn't created log entry. And if I'm checking the logs now we will see that I have a log entry. To see if this is persisted or not, I'm going back and switching the service off. Then we see that we have this folder storage as defined with 4 channels. We defined in this application YAML here, this application YAML, we have these 4 channels. And inside the code we have this folder storage defined. So now I'm starting this application again. Here we are. It's started again. Back to the terminal. Checking the logs, exactly the same logs. Greeting Mr. Joe again. Checking the logs, now I have 2. Perfect. So the persistence is running and now we can see how to wrap all this stuff in Docker. So now it's time to build a Docker image around this Helidon service because we want to distribute it later or let it run in Kubernetes or whatever. So the first thing is I'm logging into my Docker registry, and this I'm doing over the Docker desktop. Docker desktop is for me the environment to work locally with Docker itself. I have a short, small dashboard here. I can check what images are here, what volumes, containers, apps, and so on. I can configure it and so check out. Docker desktop is a very convenient way to deal locally with Docker images and runtimes at this place. And now what I want to do is I want to log into my Docker registry, and I'm using the free tier from Artifactory because I have a few positive things here. The first one is I'm getting rid of this limitation that I have with Docker Hub, because if I'm going over Artifactory I can ask as often as I want per minute or per hour for new Docker images, because JFrog and Docker, they have a special agreement that will remove, even with a free tier, the limitations regarding the Docker pulls. And the next thing is that I need a central place where all stuff is coming through, so all my Maven repositories, Maven dependencies and all this stuff, as well as the Docker images. Okay, so for this I'm logging into this registry. If you want to know how to create Docker repositories in Artifactory, check out my YouTube channel. I have some talks about this one, and I'll show you how to create Docker images, how to create these security scans, and so on and so on. So here, I assume we have this Docker repositories already. The next step is I want to remove everything that is locally, because I want to make sure that everything is clean. I'm just removing everything at this point. Sometimes you're doing the same with Maven, so if you want to make sure that everything is running with the configuration you have and so on. So and now we have to change a little bit the Docker image itself. So the Docker image from this Helidon project is finally it's completely generated for you, but I'm adding here the repository or the registry name URL, because I want to grab even the base images over Artifactory, so that I have the whole tech stack inside Artifactory that I can scan for vulnerabilities even in my build images and so on. So, okay, here is this one. What we're using is Maven within JDK 11, creating work directory, copying the POM XML, running the Maven package command without tests, and then it's more or less done. It's the first step. So I will grab everything inside this Docker image. So it's like a plain machine. So that's a good thing if you're building inside Docker, so you don't have to clean your own system. You're just creating a new image here. And then the next step is I'm using the OpenJDK 11 image, the official one, grabbing this one over Artifactory as well, copying just the jar and the libs and defining the command and exposing the port 8080. So now I want to do this one, and this will take some time, so I'm not showing the whole thing here, but what we need is a Docker command. This is just docker build -t Helidon and so on and so on. And now it will start. And as you can see, it will start pulling metadata from Sven R -docker -jfrog and will start building the Docker image. So this is now running a while, and see you in a second. The Docker image is built. It took a while, but now we have all the steps here, and everything was running over this Artifactory instance, so that we have the central point where all binaries are going through, even from the build cycle. And now it's time to start this Docker image once. And this is easily done. So with Docker run and so on and so on. And after we started this Docker image, we have this message, okay, localhost 8080, it is exactly this one. And now we can again check the logs. No logs in because it's a fresh one. Then we are just greeting Mr. Joe, hello, and now logs again, and it's working, at least there. So now we could stop the Docker image, start the Docker image, and showing that persistence is working, and so on and so on. Regarding persistence and volumes, make sure that you are not just writing inside your image, so define a volume, define path, and so on and so on. So don't forget the best practice with Docker, but this one is running. So the next step would be just here to tag this one with version. I'm taking this one, it's the second version of today, and then we can push it. And again, this push will be to my Artifactory instance. I'm using Artifactory instance, a free tier here. And the good thing is that I have now all binary there that I'm using during the build, and I'm pushing all my binaries on the Docker images to this one as well. And now I can analyze with X-ray, the security scanner, for known vulnerabilities and compliance issues of the whole tech stack. And not only about the final product, I can do it over the whole component base I have during the whole life cycle. So from writing the first line of code up to pushing to production. Okay, this is pushed now, and let's see what we can do next. We created a Docker image, we tagged it, we pushed it to Artifactory so that we have this in a central place for distribution as well, for license and vulnerability scanning. The next part would be how it looks like in this web UI. I'm not covering all these details, way too much for this presentation here, but if you want to have more knowledge how to ramp up these repositories, how to get a free tier from JFrog, check out my webinars under jfrog.com, or just attend one of my workshops, or you can subscribe my YouTube channel. You will find a bunch of information there as well. And I really would like to welcome you as my new subscriber. So if you like this video, by the way, then thumbs up and subscribe my channel, please. Okay, what's the web UI? Inside this web UI, if you log in, then you can go here to the Artifactory and artifacts, and there you will see all these different repositories that are defined, how to define repositories. As I mentioned, check out my how-tos. And here I have my Docker repository, and inside this Docker repository, I'm here on my Halidon Quick Start version 002 would be pushed just a few moments, and I can check here different informations, for example, different steps inside my Docker images and so on. But we want to scan against known vulnerabilities. For this, I have to go to security and compliance and watches. So the basic idea is that you are defining policies with a bunch of rules. It's the definition what should happen if you're finding a CVE value from A to B, CVSS value from A to B. And then with this, you're creating watches. Watches is an association, what should happen and what you want to scan. So it could be a composition of Docker, Maven, whatever repositories inside a watch. And if you have done this one, you can go here to watches and violations and check out how it looks like. Here I created ones already that is scanning all my Docker images I have here. And the first one here is, this is an Docker image JetBrains Team City. It's a CI environment from JetBrains, and there is something in, for example, here. This is something in Neticodec, and there's a fixed version available here. You can see, okay, 4.1.44 final is a fixed version for this one. You will get some information about the CVE so that you can scan or search externally for more information in different databases. You will get references to documentation that's describing what's going on here. You see what components are affected, and on the right side you will see the full impact graph. So you see this codec jar is inside this dependency, language, service, whatever, inside this Docker layer, inside this Docker image from TeamCity. And then you can switch to a different view, and this is based on what is not the declaration, it's here what is a file that's containing this affected or infected binary. So, and that's more or less all at this place. You can get all this information via a REST API out of it in a machine readable way, so that it can feed other components or tools or whatever is necessary for you. And that will give you the possibility to interact with existing infrastructure on your side as well. So, okay, so I'm not able to show you all the details here about the X-ray and the vulnerability scanning and how to create repositories. For this, check out my YouTube channel or attend my webinars or workshops here for free. If you have a Java user group or some meetup, just invite me and I can give your community some free lessons about all this stuff. And yeah, let's see. So that's all about having Docker image or Maven dependencies or whatever, everything what I'm grabbing and everything that I'm producing, pushing to Artifactory, and inside I'm scanning the whole impact graph from build stages up to what is pushed to production. And yeah, so I'm protecting more or less the whole supply chain from this point of view. Okay, this was really a lot of stuff. So we started with object-oriented persistence, compared it to different other paradigms, and I showed you how to speed up this one, how to implement your first Hello World with this open source tool that will give you object-oriented persistence inside the JVM. It's called Microstream, and showed you how to find it on GitHub. We wrapped this persistence inside another open source project called Helidon from Oracle, and here we have the reference implementation where you can use inside microservices this kind of persistence already. Then we wrapped everything in Docker because we want to use it later in some Kubernetes or whatever environment, and this Docker image we just pushed back to Artifactory where we grabbed all binaries from, and we pushed all binaries through, so that inside this place we first of all getting rid of these limitations of Docker Hub in pulling, and the next thing is we can scan the whole tech stack against known vulnerabilities and compliance issues. Everything is for free available. Microstream is open source and free, Helidon is open source and free, and the free tier from JFrog is available. So at this point I can say thank you very much for attending here, and if you have a community or if you have a Java user group, a meetup group, whatever, and you want to have some deep dive, practical deep dive with workshops or dedicated talk to some of these topics I mentioned here, feel free to contact me via Twitter, LinkedIn, YouTube, Instagram, whatever. The only thing that's not working so good is email, but we will find a way to stay in contact. So whatever time you're looking at this one, thank you very much for your attention, and if you like it, check out my YouTube channel, give me some thumbs up, and be my new subscriber. Stay safe, and the last thing I can say is see you.